Hello everyone. Today we are going to discuss about deterministic finite automata definition. So let's start.
So generally, if we are talking about a deterministic finite automata, then it should be represented with a phi tuple notation. So before going to design a deterministic finite automata, let us understand the phi tuple notation of a DFA. So it will be represented with M equals to Q sigma delta Q naught F. This is the phi tuple notation of a DFA. Okay, so a phi tuple notation of a DFA can be represented with Q, sigma, delta, Q naught and F. So what is this Q? This Q is the finite set of states. Q is the finite set of states which is represented as Q0, Q1, Q2 and so on. So generally if you are going to design a finite automata, it will be represented in the form of a states. So states can be represented as Q0, Q1 and Q2 and so on. So depending upon the number of input strings you use, so that will be represented by using this set of states. So DFA will be represented with states. So that is called capital Q. This sigma is the finite set of input symbols, or we can also call it as alphabet. So sigma is also called as alphabet. So what is alphabet? Alphabet is the finite set. Set means collection of elements, right? That elements might be either states or a input symbol. So finite set of input symbols. So these input symbols can be digits, that is 0, 1, 2 or so on, or it can be letters, that is A, B, C, small letters, or it can be capital letters also. So depending upon the type of input symbols, in the question how it was asked, we will take that as the alphabet, that is sigma. So Q is the finite set of states and sigma is the finite set of input symbols. So based on this states and input symbols, we are going to write the finite automata. So now we understood what is Q and what is sigma. What is this? This is the delta. Delta represents the transition function. So delta is transition function. So delta is a transition function. In deterministic finite automata, we represent the transition function as delta such that Q maps sigma gives Q. So what is this? Q means set of states that is present in Q. When it is making a transition over any input symbol, whether it might be 0, 1 or it might be AB, it is giving rise to the same state that is present in Q. So how we can write it as the transition function can be written as delta of Q, any state in general. We will consider one particular state, Q naught over sigma. Sigma means any input symbol, that is A, gives rise to Q1. In this way we will represent, means if you take any state, after reading the input symbol A, it is moving to the next state, that is Q1. This is the transition diagram, and the transition diagram can be written as transition function in this format. So Q naught on reading input symbol A, moving to the state Q1. So that will be written mathematically by using the transition function, that is delta of Q naught on reading input symbol A going to Q1. Q naught on A, Q1. Q naught on A is Q1. So in this way we will represent the transition function. And next one is Q naught. Q naught is the initial state of the DFA. Means definitely if you want to start any system, then it should start from the initial state. So initial state will be represented with Q naught. Okay, so that is Q naught, and F represents the final state. So in a transition diagram, the initial state will be represented with the arrow pointing to a circle. This is initial state. In final state in DFA or any finite automata can be represented with two concentric circles. This is final state. So before going to design any deterministic finite automata or a non-deterministic finite automata, then you should know these steps. So what is that? You should know what are the states and what are the input symbols and how to write the transition function or the transition diagram, and you should know what is initial state and what is the final state. Okay, so this is the general representation of deterministic finite automata. Thank you for watching my video. Please like, share and subscribe. Thank you.